Friends, welcome to the class. Today we will discuss about arithmetic progression. What is arithmetic progression? The definition says an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. That means if a1, a2, a3 continues up to an are the list of numbers such that a2 minus a1 equals to D, A3 minus A2 equals to D, A4 minus A3 equals to D, and it continues up to AN minus 1 equals to D. Then the given list of numbers A1, A2, A3, A4 continues up to AN are said to be in AB. Here each numbers A1, A2, A3 these are called as the terms, and the constant number, the difference between the two consecutive number is known as common difference. Here we have represented the common difference as D. A2 minus A1 equals to D, A3 minus A2 equals to D. This D is known as the common difference of the given AP. So, an AP series can be written as A plus D, A plus 2D, A plus 3D, and so on. If the number of terms in an AP is finite, then it is called finite AP. Otherwise, it is called an infinite AP. So, an infinite AP do not have last term. Let's see an example. Examine that the list of numbers form an AP or not. If it forms an AP, find the next two terms. So the first example is 5, 8, 11, 14. Second one is root 5, 2 root 5, 3 root 5, 4 root 5, 5 root 5. Okay, let's solve the first one. The given terms are 5, 8, 11, 14. So we have A2 minus A1 is 8 minus 5 equals to 3. A3 minus A2, 11 minus 8 equals to 3. A4 minus A3 is 14 minus 11 is 3. So it is clear that we are getting the same common difference. Since the difference of any two consecutive terms are same, the given term form an AP. So then the next two numbers can be found out as 14 plus 3, 17, and 17 plus 3 is 20. Let's solve example 2. The given term are root 5, 2 root 5, 3 root 5, 4 root 5, 5 root 5. Let's see whether we are getting the same common difference. Here A2 minus A1 is root 5, A3 minus A2 is also equals to root 5, A4 minus A3 is also equals to root 5. Since the difference of any two consecutive terms are same, the given terms form an AP. So we can find the next two numbers. The next two numbers are 5 root 5 plus root 5 equals to 6 root 5, and 6 root 5 plus root 5 equals to 7 root 5. Friends, let's take another example. Check that the list of numbers defined by an equals to 3n minus 1 is an AP or not. If it is an AP, find the common difference and third and fourth term. So the given number is defined by an equals to 3n minus 1. So we can find an plus 1 as 3 into n plus 1 minus 1, which is equal to 3n plus 2. Now an plus 1 minus an is nothing but 3n plus 2 minus 3n minus 1, which is equals to 3, which is independent of n. So it is clear every time if we go for finding the common difference, we are going to get 3, because here an plus 1 minus an is independent of n. So the list of numbers defined by an equals to 3n minus 1 is an AP, and the common difference is 3. Now let's find the third and fourth term. Now the third term is when n equals to 3. So A3 is 3 into 3 minus 1, which is 9 minus 1 equals to 8. And the fourth term is A4, which is 3 into 4 minus 1, which is equals to 11. Thus, the common difference of the given AP is 3, and third and fourth terms are 8 and 11 respectively. Now, nth term of an AP. It says if the first term of an AP is A and its common difference is D, then the nth term is represented by An equals to A plus n minus 1 whole into D. The nth term of an AP is also known as the general term. So the nth term is given by A plus n minus 1 whole into D. If there are n terms in an AP, that means the nth term is the last term and it is represented by L. So we can write L equals to A plus n minus 1 whole into D, where A is the first term and D is the common difference. Let's see an example. Find the 11th term of the AP. Here the given AP is 11, 7, 3, minus 1 and so on. So here the first term A is 11 and the common difference is 7 minus 11 or 3 minus 7. It is equals to minus 4. Now the nth term is denoted by An equals to A plus n minus 1 whole into D. So putting 11 in the place of n, we are going to get the 11th term. Let's see. The 11th term is A11 equals to A plus 11 minus 1 whole into D, or A plus 10D, which is equals to minus 29. Thus, 11th term of the given AP is minus 29. Let's see another example. The first term of an AP is 5, common difference is 3, and last term is 80. Find the terms. So here what is given? Here the first term A is given, common difference D is given, and the last term L is given. But the number of terms n is not known to us. We have to find out. We know L equals to A plus n minus 1 whole into D. So we can put the respective values of A, D and L so that we can find out n. So 80 equals to 5 plus n minus 1 whole into 3, or n minus whole into 3 is 80 minus 5 equals to 75, or n minus 1 is 75 by 3, which is 25. Thus n equals to 25 plus 1, 26. That means the AP contains 26 number of terms. Let's see another example. Which term of AP 3, 8, 13, 18 and so on will be 130 more than the 31st term? So in the given AP, A equals to 3, D equals to 5, we have to find out the number which is 130 more than the 31st term. So first of all, we have to find out the 31st term, and then afterwards we can find out the other term which is 130 more than the 31st term. So what is 31st term? A31 equals to 3 plus 31 minus 1 whole into 5, which is equals to 153. Let the nth term is 130 more than the 31st term. So An equals to 130 plus A31. We know An is represented as A plus n minus 1 whole into D. So a plus n minus 1 whole into d equals to 130 plus 153. Putting the values of a and d in the respective places, we're getting 3 plus n minus 1 whole into 5 equals to 283, or n minus 1 whole into 5 is 283 minus 3 is 280. So n minus 1 is 280 by 5 is 56. So n is 56 plus 1, 57. That means the 57th term is 130 more than the 31st term. So the required term is 57. Let's see another example. Determine the general term of an AP whose 7th term is minus 1 and 16th term is 17. So here neither the first term nor the common difference is given, but we have to find out the general term. Let A be the first term and D is the common difference of the AP. So what is 7th term? A7 is A plus 7 minus 1 whole into D, which is equals to minus 1, or A plus 60 equals to minus 1. Let this be the first equation, and the 16th term is denoted by A16 equal to A plus 16 minus 1 whole into D equals to 17, or A plus 15D equals to 17. Let this be the equation 2. Subtracting equation 1 from 2, we get A plus 15D minus A minus 6D equals to 17 minus minus 1. Plus A minus A gets cancelled. 15D minus 60, 9D equals to 18, or D equals to 2. Putting the value of D in equation 1, we get A plus 6 into 2 equals to minus 1, or A plus 12 equals to minus 1, or A equals to minus 13. So we got D and we got A. Now we have to find out the general term. We know the general term of an AP is denoted by AN equals to A plus n minus 1 whole into D. So by putting the respective values of A and D, we can derive the general term. So AN equals to minus 13 plus n minus 1 whole into D, or on solving we are getting AN equals to 2n minus 15. So the general term of the given AP is 2n minus 15. Now, nth term from the end of an AP. Let A be the first term, D is the common difference, and L is the last term of an AP. Then the nth term from the end can be found by the formula L minus n minus 1 whole into D. Let's see an example. Determine the 10th term from the end of the following AP. The AP is 4, 9, 14, continues up to 254. So here A is 4, D is 9 minus 5 or 14 minus 9, which is equals to 5, and the last term is L. L is 254. We have to find out the 10th term from the end. So as I said, here A is 4, D equals to 5, and L is 254. So by putting the respective values in the given formula, we can find the 10th term from the end. So the 10th term from the end is L minus n minus 1 whole into D, or 254 minus 10 minus 1 whole into 5, which is 254 minus 9 into 5, or 254 minus 45, which is equal to 209. So the 10th term from the end is 209. Let's see another example. In an AP, A equals to 10, D equals to 5, and N equals to 100. Find the 25th term from the end. Friends, here A is given, D is given, N is given. But the last term, L is not given, and we have to find out the 25th term from the end. So before going to finding the 25th term from the end, we have to first find out what is L. Given that a equals to 10, d equals to 5, n equal to 100, and L is unknown to us, we know last term of an AP, L is represented by L equals to A plus n minus 1 whole into d. So L is 10 plus 100 minus 1 whole into 5, which is 10 plus 99 into 5, or L equals to 505. Now, nth term from the end is L minus n minus 1 whole into d. So 25th term from the end is 505 minus 25 minus 1 whole into 5, or 505 minus 120, 120, or it is equal to 385. So the 25th term from the end is 385. Friends, here we saw a few examples. The more you practice, the easier it becomes and the more you like it. So friends, do practice more and more questions, more examples. And if you come across any difficulty, do share your question with me. It will be a pleasure for me if I can help you out in solving the questions. So this much for today's class. Thank you.